Hey everyone, welcome back to another episode of GetAIed. For those who are new to this channel, this is just about exploring the AI space. For the past two episodes, we've just been exploring the AI in general, the history, what are the basic applications in life, and we were going through some trendy tools as well. And this episode, we'll be learning more about machine learning, deep learning, and also we'll touch about on the foundational life cycle of the foundational models. And also, we'll talk about computer vision and natural language processing. This is a two-part video, so we'll just talk on the first few topics on the first part, and stay tuned for the second part as well.
Right. So here I have made a small deck on machine learning and deep learning. So this is basically to understand the core concepts and their applications in our daily life. And this deck was made from a AI called Prezi AI. So it's basically for making PowerPoint presentations. So you just have to type in all the descriptions or your prompts, and then the AI makes the deck for you. So that's one thing that's been made easier by the AI. So let's see a Venn diagram which showcases how deep learning and machine learning is uh, connected with artificial intelligence. So as you can see here, deep learning is a subset of machine learning and machine learning is a subset of artificial intelligence. As we discussed in the last episode, artificial intelligence is or AI is this basically making the machine smart. So how does it achieve that? So it basically achieves that through machine learning. So, machine learning is a concept where it uses statistical methods to automatically learn and improve based on experience. So, it basically predicts based on the past data. So, if you give a input on the current sales trend or the past year's sales data, it tries and predict you the sales that can happen on a future date. It might not be exact or it might not be the right prediction, but it is based on the past data. As you can see, any sales data can be altered or it can be impacted by the external factors, but in this case it's purely based on data, and the way it's being trained is a big factor. How the machines are or how the testing data or training data is given is a big factor, but still the basic concept is we give the data and machine learning or that the algorithms try to predict the future information. And then comes the subset, deep learning. Deep learning is a subset of machine learning where it actually uses a complex algorithm which mimics the neural network of our brain better. So that's deep learning can be seen in every application of every uh, fields of our life. So chatbots, voice agents, automated cars, everything is basically run on deep learning. So let's see the definition of machine learning. And machine learning is basically it's a subset of AI that equips computer to learn from data without being explicitly have to be programmed for every single scenario. So think of it like training your dog. So you say it to stand, stay, sit, whatever it is. So based on those patterns, the dog tries to do, or respond correctly the next time. So based on the pattern you give or based on the sounds you use it to train it, it responds to you in the correct way. A common ML algorithm is linear regression, where computer finds the best fitting line to predict a value, like the house prices based on the size. Right. Now let's see the definition of deep learning. Deep learning is a subfield of machine learning inspired by the human brain. So it basically uses artificial neural network, which is like a complex network of interconnected neurons that process information in layers. So imagine a complex network of specialists which are working together on a big problem. So each specialist or neuron focus on a small part of the problem, and their combined effort uh, solves the bigger puzzle. So deep learning is basically that. So each part is given to a specialist and the whole team of specialists try to solve the problem. So that's how deep learning works. So deep learning excels at learning complex patterns from vast amount of data. much more than the traditional machine learning algorithms. So this is what is making the DL so powerful. So now let's see some examples of machine learning applications and deep learning applications. So as we mentioned earlier, machine learning and deep learning is one and the same, or deep learning is a subset of machine learning. So the applications also is same. For deep learning, a bit more advanced technologies like autonomous cars, chatbots, natural language processors. Oh, sorry, the natural language processors in the chatbots, facial recognition in smartphones. So all these are like examples of deep learning, which is embedded in our daily lives as well. Move ahead and dive a little bit deeper into the deep learning part. Let's try and understand the neural network. So this is a symbol depiction of the neural network, and it's made up of nodes, basically nodes or neurons, and it's organized into layers. So this is the input layer where it receives the initial data, for example like a pixel of an image, and then there is a hidden layer where the magic happens. So these hidden layers have the nodes which performs, or the neurons which performs a symbol calculation. So this scrambled image or a pixel of an image are then processed in these layers based on the algorithms, and it tries to predict an output. So all of this works together, and then together the information it processes tries to give an output or an image. So the output layer basically provides the result, like the identified object of the image. More the layers in this part or the hidden layer, more complex patterns can be identified, or the network can learn more patterns. So let's see once again the layers of neural network. So neural network typically includes a input layer, which is the receiving end, and then one or more hidden layer where the processing of the information happens, and then the output layer where the results are delivered. So each additional layer enhances the ability to learn more complex patterns, making them effective for tasks like image recognition or speech recognition. Okay, so now let's see some applications of deep learning. So there are two major applications of deep learning: computer vision and natural language processing. Computer vision empowers machine to interpret and analyze visual data. Basically, what it does is it enables the computer to see and interpret images and videos. Facial recognition or autonomous car detecting pedestrians on the road. All these are like the applications of computer vision. Computer vision is influencing many industries like security, automotive, healthcare, and the efficiency and accuracy is getting better day by day. So we can see in the future maybe there won't be, no one will be driving a car, it will be full of autonomous cars, which basically uses the computer vision to analyze the external environment and act accordingly. And now let's see the application, another major application of deep learning, that's the natural language processing. Natural language processing basically enables machine to understand and interact using the human language. So basically, if you say in English or any other language, and if the application can respond to you or give the information back to you, make a website, make a presentation for you, make a video for you. So that's basically the natural language processing is. So you might have seen already the applications in chatbots, language translators, customer service interactions. Now things are getting really interesting with generative AI and foundational models. Let's start with generative AI. This is AI that can create new content, text, images, even code. So think of AI as not just understanding the world, but being able to imagine and create new things. So if you go into ChatGPT and if you ask it to write a new script for a new video, or for a YouTube video, or a lecture, or even a speech which you want to present in your class, it does it for you. It's basically creating content. It doesn't stop with text. It goes to the next level and creates music as well. So there is an AI called Suno. What it actually does is you put the description or you put the prompt on what you want as the song, and it tries to create the music for you. So that's how good generative AI is as of now. Now let's have a look at the foundational models. A foundation model is a type of AI model that's trained on the large amount of data that and can perform a variety of tasks. They are also known as base models. These foundational models are like a self-supervised. They use the self-supervised learning to process a large amount of unlabeled data. So these foundational models are pre-trained on a set of data, and then after a point, they also do like self-learning based on the feedback loops, uh, and try to be a better model. I would say that. Um these can be adapted to perform a wide range of tasks such as image classification, question answering, and natural language processing. These usually create outputs like text, images, codes. So some examples of foundational models are ChatGPT, Gemini, Copilot, Let's Chat. So these models are built on a pre-trained set of data. The new one as well, the DeepSeek. So these models are built on a pre-trained set of data, and based on the feedback loop, if they have done or if the prediction is correct, then it gets a treat, or like it gets a positive feedback, so that the next time it predicts, it's much more accurate. All right. Now let's go into the life cycle of a foundational model. How a foundational model is built, how ChatGPT is built, or how Copilot is built. First step is data selection. It's the important part. This is very important. So just to get the right data, right quality, right quantity is very crucial. This is what determines what is better. Is it ChatGPT is better, or Gemini is better, or Copilot is better? It's based on what data is what data is selected for the foundational model. The next step is pre-training. It's basically the model is trained on a massive data set. This is where the model learns the general patterns and knowledge. And next step is optimization. So each of the foundational models have their own specialization. Even though they are a generalist, they try to be a specialist on a uh, particular trait. So for Copilot, it might be coding. For ChatGPT, it might be generative AI or content creation. Uh, for each foundational model, they have a niche which they are looking at. So this in this stage, the generalist is becoming a specialist. And the next one is performance evaluation. The fourth step is evaluation. So once it's optimized, we need to evaluate the model's performance and make sure it's doing what we need. Once the performance is evaluated, it is then deployed. So deployment. So once we are happy that the model is performing based on our requirement, we deploy the model and make it available for use in applications or services. And the final step, and the most important step of all, is feedback and continuous improvement. Post deployment, gathering feedback is essential for the ongoing success. Once it's deployed and we get the feedback from the real world, and the found model tries to improve it continuously, so based on the inputs is that it gets from the real world, it trains itself, or it does the self training to get the better result the next time. So it's like a feedback loop. So you do a prediction, and if it's right, then it gets a plus point, and then the model trains itself to predict it the right way the next time onwards.
Okay, let's have a quick recap on what we have gone through today. And this recap video is made by a AI video editor, InVideo.ai. And also the presentation is made by a presentation AI that's called Prezi AI.
Exposing the secrets behind your smart devices. Ever wondered how your phone recognizes your face, or how Netflix know what exactly you want to watch next? It's all thanks to machine learning and deep learning. So what's the difference? ML is like training your dog. You show it examples and it learns from them. Imagine teaching a computer to predict house prices based on size using a symbol graph. That's ML in action. Now, deep learning or DL is next level. Imagine a team of specialists each handling a tiny part of a big problem. That's DL using artificial neural network inspired by human brain. It's why DL can recognize faces and understand language with incredible accuracy. So next time when you use your smart device, remember it's ML and DL making the magic happen. Let's break down a neural network. It's made up of nodes or neurons organized into layers. The input layer receives the initial data like pixels in an image. Then the data passes through one or more hidden layers where the magic happens. Each neuron performs a symbol calculation and the results are passed on to the next layer. Finally, the output layer provides the result, like the identified object in the image. The more layers, the more complex patterns the new network can learn. Two major applications of deep learning are computer vision and natural language processing. Computer vision enables computers to see and interpret images and videos. Think facial recognition on your phone or self-driving cars detecting pedestrians. Natural language processing allows computer to understand and process human language. This is what powers chatbots, translation apps, and even voice assistants like Siri. Things are getting really interesting now. Generative AI. This is AI that can create new content, text, images, music, even code. Think of AI as not just understanding the world, but being able to imagine and create new things. This is all powered by something called foundational models. Foundational models are huge pre-trained AI models that can be adapted for a wide range of tasks. Imagine a highly skilled generalist, someone who's learned a lot about different subjects. They can then specialize in a particular area like medicine or law much faster than someone starting from scratch. Foundational models are like that generalist. They learn general patterns from massive data sets and then they can be fine-tuned for specific tasks like writing poems, translating languages, or generating images. This dramatically speeds up AI development because we don't have to train a new model from scratch for every single task. So, how are these amazing foundational models created? It's a multi stage process we call the foundational model lifecycle. First, we need the right data. The quality and quantity of the data are crucial. Next, we pre-train the model on this massive data set. This is where the model learns general patterns and knowledge. Then we optimize or fine-tune the model for specific tasks. This is where we adapt the generalist to become a specialist. We evaluate the model's performance to make sure it's doing what we want. Once we are happy, we deploy the model, making it available for users in applications or services. Finally, we gather feedback from real world use and continuously improve the model over time. That wraps up part 1. We've covered the essential concepts of deep learning and foundational models. In part 2, we'll dive deeper into the exciting details prompt engineering, RAG, fine tuning, and different types of foundational models, LLMs, diffusion models, and more. So that's a wrap on part 1. So in this video we have discussed about machine learning, deep learning, and the life cycle of foundational models. And the next part, we'll go dive deeper into the deep learning part. We'll go through the fine tuning, RAG, and some models of LLM as well. So stay tuned. If you're interested in the AI videos, subscribe and support. Thank you.